he finally found his match.
When I was shot down in my Me-262, I pushed the plane downwards, so my plane only got hit once. I dived into a cloud, and as an experienced pilot, you know that you should not come out in the same spot. They wait for you above it. I turned 45 degrees in the cloud. They kept looking for me, but I was gone.
For 60 years, Joey had no idea what had happened to his adversary. But then, out of the blue in 2005, he received a phone call and an invitation to meet Walter. Over a couple of beers, the German admitted that he eventually had to bail out of his Me-262.
We didn't have an ejector seat, and I had to see how I could get out. I pulled myself up with both hands and pushed my foot off the joystick. And then I sailed down. It went really fast.
And on the 18th of May, 2005, Walter and I met for the second time, the first time in person, and we're the best of friends.
Joey's P-51 might have won the day, but the Me-262 marked the beginning of the end for propeller planes. Jet fighters were the future. The next leap forward in engine designs would result in breaking the sound barrier. After the war, the U.S. fitted a very small plane with a rocket engine. Like a bullet with wings, the Bell X-1 was the first plane to go faster than Mach 1, the speed of sound. In October 1947, Chuck Yeager became officially the first man to go supersonic. Roger and James were both fighter pilots in the Korean War. In the F-86 Sabre, they experienced what it's like to break the sound barrier.
It was towards the end of my tour over in Korea. My flight leader spotted some MiGs down below, and we were at fairly high altitude, maybe 35,000 feet. And we performed a high-speed dive to engage them. And then during the maneuver to get down there, we, of course, exceeded the speed of sound. But we had such an overtaking airspeed with the aircraft, or the MiGs, when we finally did get to their altitude, that we overshot them considerably. We had to pull an awful lot of G's just to recover from it. We had quite a good engagement there.
Today, modern jets go supersonic on a regular basis. Unmanned flights even reaching speeds of Mach 10. Fighter aircraft have become the fastest weapons on the battlefield. This need for speed is essential, but it's not the whole story. Fighters have to be maneuverable, and for this to happen, a whole lot rests on the wings.
If you try to turn an Me-109 as tightly as you can turn a Spitfire, the wings will come off.
Newton's law of gravity. What goes up must come down. Nice theory, until you see an F-22 Raptor in action. Fighter planes fly in the face of physics, pushing the airframe to the very edge. But to go this fast and pull these kind of moves, you need some serious engineering. Highly evolved engines, state-of-the-art avionics, most important of all, wings.
The basic structure of a wing hasn't really changed a lot. The materials have changed, some of the shapes have changed. But the basic thing is you need airflow over the wing section, and that gives you lift. Lift counteracts the force of gravity, and that's what flying is all about.
The air flowing over the wing has to travel a certain amount of distance. In a conventional wing, the distance that the air travels over the top is a greater distance than the air traveling across the bottom. If it's traveling a longer distance, it must therefore travel faster. When it travels faster, it's got less pressure. So you have less pressure on top of the wing and more pressure on the bottom of the wing, and the greater pressure on the bottom of the wing makes the wing travel upward when the airplane goes away.
Go back to World War I, and wing development was in its infancy. The big question, how many wings should planes have?
The idea with a biplane or a triplane is to have more wing to make the plane more maneuverable. If you get another wing and make yourself a triplane, then when you are turning in those tight turns, all the weight of the aircraft magnified by centrifugal force is distributed over that many more surfaces, over that much more wing.
But triplanes and biplanes had a major disadvantage. The extra weight of the additional wings, struts, and wires created more drag, slowing down the plane. In the 1930s, lighter and faster monoplanes with single wings began to appear, and a new branch on the fighter family tree was born. The major air forces began to produce a series of classic purebred fighters. Two of the best were the British Spitfire and the German Me-109. The Spitfire had large elliptical wings with low wing loading. In aerodynamics, wing loading is the loaded weight of the aircraft divided by the area of the wing. This gives engineers a rough idea of the aircraft's lift-to-mass ratio, which affects its rate of climb, load carrying ability, and turn performance.
If you compare it to the Me-109, which was its German opposite, you can see that the German aircraft has got a much smaller wing, and that means it's got a much higher wing loading. There's a lot more aircraft per bit of wing on the Me-109. And that means that if you try to turn an Me-109 as tightly as you can turn your Spitfire, the wings will come off. Because the wing on the Spitfire is so gorgeously, lavishly big, and because of that nice elliptical shape, the Spitfire can turn a lot tighter in a dogfight with an Me-109.
Any claims, Johnny? A 109 destroyed, buddy, yes. Oh, good show.
When Spitfires and Me-109s went head-to-head, and the Spitfire outturned the Me-109, the German pilot only had one chance: deploy his landing flaps.
Bei der Messerschmitt waren die Landeklappen so angetrieben, dass ich...
You could change the angle of the landing flaps electrically from 10 degrees to 20, 30 degrees and so on. The Spitfire could only do two positions, flaps down and up. The German pilot, the wily rabbit, could use it in tight turns. When the Spitfire was behind him and he couldn't keep up with its tight turns, he just changed the flaps to a 10-degree angle. Thereby he had more lift and the plane could turn better and could maneuver outside the target area of the enemy. And then he put the flaps back in and dived nose down to escape.
Great wing design helped both the Me-109 and Spitfire become legends. But they weren't the only World War II fighters breaking new ground in aerodynamics. The P-51 Mustang became the first production airframe built with laminar flow wings. Laminar flow is the smooth, uninterrupted flow of air over the contour of the wing, compared to a turbulent flow. A wing with high laminar flow should experience less drag and turbulence. Engineers applied this principle to the Mustang's wings. Its cross-section, or airfoil, was relatively thin at the leading edge and progressively wider to a point of greatest thickness at the aft. The result? Drag was reduced, lift and speed were increased.
This was a new invention back in the late 30s and early 40s. This was the first airplane to ever incorporate a laminar flow wing. In 10 or 15 years, they went from biplanes that did 120 miles an hour to airplanes like this, which were top speed of 505 miles an hour. So the advances that were being made weekly during that period of time. And the laminar flow wing was just something that was developed at that time and first put on an airplane in the Mustang.
The evolution of laminar wings was a huge step forward, but it didn't provide all the answers. With the invention of the jet engine, planes got faster, and that extra speed was putting a lot of strain on the wings and the tail.
The airflow over the top of the wing would tend to become supersonic, so that even though the plane was flying well below the speed of sound, the local airflow over the wing was at the speed of sound or above. You would create a standing shock wave, and you would have a disturbed wake behind that shock wave that would beat the tail of the airplane to death, so to speak, and it caused a lot of accidents.
Designers needed to find a wing design that could cope with the stress of supersonic flight. The solution lay in the work of an obscure German aeronautical engineer called Adolf Busemann. Buseman was inspired by the V-shaped wake that trailed behind boats navigating his hometown harbor. He took this image and in 1935 presented a design for a V-shaped aircraft wing. First, his idea got little attention, but 10 years later in 1945, the US and Germany independently developed and built swept wings. Cruising at supersonic speeds, the wings would function effectively.
The swept wing delays the onset of these shock waves and allows the pilot to maintain control of the aircraft as his speed increases.
The tailless delta wing built on the success of the swept design. Shaped like a dart, the delta forms the basis of most modern wing designs. It transformed fighters into faster and more maneuverable planes. But what happens if things go wrong? One plane down doesn't necessarily mean you lose a good man with it.
When I knew that I had a good parachute, then I was very relieved.
Today's jet fighters are the fastest, baddest birds on the block. They can destroy any target, anytime, anywhere. That's why every army in every time has tried to blow them out of the sky. Pilots live their life on the edge, knowing that just one bullet, one error in judgment, one mechanical malfunction could end in disaster. But if the worst does happen, they always have one last chance: their parachute. Go back to World War I, and bailing out of a fighter was tricky. Pilots were issued with primitive parachutes that had to be opened before they jumped out of a plane. A device was needed which would allow the pilot to jump out and get himself to a safe distance from the plane before the parachute would open. It took the genius of a stuntman in Hollywood, Leslie Irvin. Irvin worked for the film industry, performing parachute jumps from 1,000 feet. In 1918, he invented a free-fall backpack parachute and a ripcord the pilot could pull to open the parachute when clear from the plane.
The idea is that instead of having to drop out of an aircraft in order to parachute, you can actually jump out of it with a parachute that will subsequently open and enable you to descend safely to the ground.
Irvin's invention was adopted by air forces around the world. All told, it saved the lives of over 10,000 aviators. But parachutes on their own aren't always enough. The introduction of jet power vastly increased the speed of planes, making it virtually impossible to bail out with a parachute.
The only way to do it is to blast yourself out of the path of the plane. You want to blast away from the tail fins, you want to blast away from the wings, you just want to be away from the plane, because it's going to hurt you.
In 1938, German engineers came up with a solution. They built an ejector seat powered with compressed air. When triggered, the pilot and the seat would shoot clear of the plane. But the ejection process wasn't easy. It would involve a series of crucial steps.
The first thing is he has to bring himself in an upright position. When he activated the trigger lever, the compressed gas comes from the valve to this cannon. It creates a pressure and slides the whole seat out of the tracks from the cockpit.
Once free of the plane, the pilot had to manually open the harness, release the seat, and pull the cord to open the parachute. After the war, countries around the world carried out further research into ejector seats. In the summer of 1946, British company Martin Baker conducted the first live flight test ejections.
As the seat leaves the plane, the stabilizing drogue preventing the seat turning over in the air opens and then pulls out.
Ejecting closer to the ground was still a challenge. A more propulsive force was needed to fire the pilot high enough for his parachute to safely open. In 1960, Martin Baker came up with the underseat rocket.
Watched by members of the world press and observers from the United States, Doddy Hay pulled the pace blind, which resulted in an ejection height of over 300 feet.
His design had enough explosive force to fire the seat and pilot to a safe height, even when the plane was on the ground. In the last 40 years, they have saved the lives of countless pilots. One of the lucky ones is Ralph Harrison, a Canadian Air Force starfighter pilot stationed in Germany. On a cloudy day in 1980, he went on an exercise at 1,500 feet. Just minutes into the flight, he heard a succession of explosions, followed by a deafening bang.
There was smoke going in the cockpit. So the only thing going through my head was, what do I have? Can I solve the problem? Can I fix it? And then I realized I couldn't fix it.
Known as the missile with a man in it, the stubby-winged Starfighter was the first U.S. jet fighter in service to fly Mach 2, twice the speed of sound. But soon after it entered service, it became one of the most accident-prone fighters ever produced, giving it a whole new nickname, the Widowmaker.
Because the F-104 doesn't so much have wings as it has stumps of wings, it's like a leaf twisting and turning as it falls through the sky, but it's twisting and turning and falling through the sky twice the speed of sound.
It looked like Ralph Harrison was going to become another victim of the Starfighter curse. As his plane began to disintegrate, his only hope was his ejector seat.
After the canopy goes, the seat fires, and everything works automatic. There's a seat kicker. It actually throws you out of the seat. And then the parachute opens, and this whole sequence is about 3 seconds. So it happens pretty fast.
The Starfighter hit a field, exploding in a giant fireball. And Harrison, well, he had a great view.
I enjoyed the view, I enjoyed the parachute ride, and the trip down was quite pleasant.
Flying fighter planes is always going to be a risky business. And in dogfights, those risks go through the roof. That's why the evolution of combat tactics is one of the most important branches on the fighter's family tree.
When a pilot finds himself with an airplane at his 6 o'clock, he knows he's in very serious trouble at that point.
In the 21st century, jet fighters are multifunctional. Ground attack, air defense, intercepting. They've got all the bases covered. Rewind to World War I and combat